Hello everyone, welcome to Chapter 1, Introduction to Networking. Let's jump down here a couple, there we go. We're going to look at what's the difference between a peer-to-peer and a client-server network. We're going to look at applications and protocols, hardware devices, physical topology, and end with the OSI model. Topology refers to how the parts of the whole work together. Okay, well that's a good definition. Physical topology refers to the network's hardware. So that is the computers, the switches, the routers, anything that is physical, the fiber, the radio antennas. That's the physical, how they are connected. We'll work on doing a physical topology diagram. Logical topology is how everyone communicates together over the physical topology. The physical topology connects everybody together physically. The logical topology is how we communicate from one device to another or host to another. And yes, network operating systems, not really quite the definition, but we'll slide right by that. So a peer-to-peer network is what you would have at home. This computer controls itself, this computer controls itself, this computer controls itself. There's nothing in charge. If this guy wants to share a file over here, he has to do it. Everybody can have different passwords and names and settings. So a peer-to-peer network works really fine at home or in a small business. Microsoft says that anything above 10 people should have a server-based network. So client-server-based networks are what we typically work with in business. When you are surfing the internet and you're going to Blackboard, you are using a client-server network. You are the client and you're using the application, Chrome or whatever you're using, the web browser, to access information from the blackboard.com server. So wncc.blackboard.com is our server that provides all the Blackboard information. You as a client are consuming those services. So in a client-server network, resources are managed by a network operating system. And in D1, for example, it's managed by Windows 2025 server. A Windows domain is a logical group of computers that Windows Server can control. It's like a security boundary. A password on the server for a domain user password on the server allows you to log into any computer in the room. That password does not apply anywhere else, as D1 is totally isolated. Active Directory is where all that information is stored. It's a directory of all the computers, the printers, all the users, and passwords and settings for all the computers. It's all centralized. So if we go a little bit further, that's your typical client-server network. There's some sort of a server. It has the domain database, which is all the users and computers in it. And from here you can determine the usernames and passwords for these computers. You can set up the printer from one place. You can control the security of each machine, all from one central location. That's what a typical business has. Okay, so for example, we just did this example. You make a request from your web browser, the web server provides that network service. That's a client-server network. You are using your computer as a client, the server provides you information. Protocols. Protocols are agreed upon methods of communication between people. There's a protocol to how we say hi to people. Typically, I say hi to someone and say, hi, Jackie, or whatever the first name is. How are you doing? That's a standard protocol for the Midwest when you see somebody that you know. It's also a standard protocol for people in the Midwest to wave at each other in their cars, even if they don't know each other. So in networking, TCP, Transmission Control Protocol, we do have lots of acronyms to learn. Transmission Control Protocol controls the transmission. Well, that's kind of redundant explanation. It makes sure that the packet gets from point A to point B to point C. It doesn't have anything to do with the destination. It is just how the packet is delivered. This has to do with the destination. This IP address is like a street address. Like I live at 615 Mountain View Avenue. The school is at 1601 East 27th Street. Those are all logical addresses. TCP/IP is a suite of protocols. So there's a bunch of things that work together for us to communicate over a network. And there's lots of services that we use. We use web services all the time. Email services, yep, we use those directly. We use the web service directly. DNS provides a service that we use indirectly. When we type in a website, there we go. If I go up here and type in a new website like google.com, computers don't understand words. However, DNS translates this to an IP address. Computers do understand IP addresses. An IP address is a logical number. We'll get to what those look like later on. Well, actually, an IP address is like this. That is a specific logical address of maybe the gateway of your network. Just like DNS, we use database services all the time, but we don't use them directly. We go through a web service to get to the database service. For example, again, we're back to Blackboard. Everything in here is stored in a gigantic database. FTP service is not something we use very often. Remote access, well, that's how I work from home and can manage all the computers in D1. It's very common for network administrators to manage everything from another location. All right, so you may not know it, but this is really what happens to email. In most cases, this is going to be a web browser. However, the communication channel works the same. If you're using the Outlook client like I have on my computer, the Outlook program, then I would be sitting there with my Outlook program. So the sender sends a message to the post office, right? This is an SMTP server, Simple Mail Transfer Protocol. This server says, oh, well, you're sending a message to Hotmail, so I'm going to send it to the Hotmail server. Then that email from loringw@wncc.edu goes to this server, Hotmail, and it says, oh, this goes to williamloring@hotmail.com. So it's very much like the post office. You go to the post office, put in a letter to your mom, it goes to your mom's home, and then eventually it gets to your mom. Same idea, and then the same thing in reverse. Fred sends a message to his email server. That email server sends it to whoever they're sending it to email server, and then it gets back to the other person. Everything works like this for communication, texting, all that. Okay, so we don't need that. So hardware, this is the physical layer. That's something we'll get into a little later on. The OSI model divides networks into different layers so that we can better understand it and troubleshoot it. So the physical layer is the physical connections. And most often in networking issues, it's a physical problem, like something came unplugged, it's not turned on. These are all physical connections. This has nothing to do with IP addresses or TCP or anything. This is only the physical hardware connection. Now we're talking about physical networks. A LAN, or a local area network, is usually in a small space, like my house. I have a local area network here. You have a local area network at your home. D1, the classroom, that's a local area network. The main campus at WNCC is a local area network. Most businesses in a single building are a local area network. So we have switches that connect from one computer to another, just like this. See this switch, how the switch is right in the middle, and it connects everybody together. This is called a star topology. You can see why. This is the central point, and then we have kind of a star. Okay. So a network interface card, in most cases with all your devices, it's going to be a wireless network card because you're communicating through radio waves. So there's three transmission media types. There's wires, which are usually copper. There's fiber, which transmits by light. and there's radio waves. Okay, so at WNCC, we have something more like this. At your home, in D1, I just have one switch. WNCC has switches all over the place because it is not very efficient to run all the wires from every place at the WNCC main campus to one central location. So they have what are called wiring closets. So this will connect up, for instance, the class computers in my room. These will connect the computers together in the business office. These might connect the computers together in student services. And down in IT, they have one switch that would connect everybody else. Typically that's called a core switch, the one that's in the middle of everything. At home, you have one. You have a wireless router that has a switch. You may or may not plug a network cable into it, but it is the central switch and there is no other switch, so you're good to go. A router creates networks. It divides your network from another network. So for instance, my network at home is connected to the internet, just like yours is. The router is the device between me and the internet that allows traffic to go back and forth. So a router creates networks. It connects networks. It goes from one network to another. So my local area network is connected to a wide area network, which is what the internet is. Wide area network just meaning it traverses long distances and typically uses a different type of networking topology. So at home, you'll have what's called a SOHO network, small office, home office. You'll have a switch, router, wireless access point, the whole thing in one device, which is what I have here. I have the same thing at home. At WNCC in the IT server room, they have a router that is specifically a router. They have a switch that only does switching. They have wireless access points all over the building that just do wireless. Same thing in D1. I have a couple switches that connect all the computers and servers together. I have a router that is a standalone router. I have it's also a firewall, router firewall. And I have a wireless access point. They're all separate devices. When you get to be a business, separate devices are more reliable and they have more power, which you need in a business. You need more power. Always need more power. So is a router have to have a firewall in it? No. So for instance, at WNCC, they have a router connecting everybody together, but they're not necessarily filtering traffic between these different networks. So for instance, this might be Sydney, this might be Kimball, this might be Scotts Bluff. They're different physical locations, or they could be in the same building. This is a separate network, this is a separate network, this is a separate network. So if this is D1, my router is a firewall, right? However, here in the business office, they're connected to a router which makes their network separate from WNCC Internet, the wireless network. So routers create networks. Wide area networks. Well, the Internet is the biggest wide area network there is. We have a wide area network. At the college, we have Sydney, Scotts Bluff, and Alliance. They're connected over wide area connectivity. Allo actually carries our signal from one campus to the next. Rarely do you use these other terms. Usually we refer to things as either a wide area network or a LAN. I've never heard anybody say MAN or PAN or BAN. Yeah, wireless local area network is usually just called a wireless network. SAN, yes, we do use. We're not going to get very much into storage area network. That means a bunch of disk drives connected together by a network. That is a much higher end enterprise level sort of thing. The OSI model. Okay, the OSI model. This is a simplified version of it. Down here we have the hardware. And we have the operating system. And then we have the application. So the web browser, Google Chrome, talks to the operating system. The operating system talks to the hardware then sends information over the cabling medium, whatever transmission medium you're using. They're separate so that one device doesn't have to do everything. The browser just has to know how to be a web browser. The operating system just has to know how to be an operating system. So here we have a better view of the OSI model. We divide it up like this to understand how it works and how to troubleshoot it. Physical layer means is everything connected together. Okay, well that's usually easy to figure out. You either test the cable, you make sure the power's on, you make sure that the antenna is connected to the wireless access point, physically connecting everything together. Now the next layer is how do we identify each network host on the network? Well, that's done by something called a MAC address or hardware address. So I'm going to bring up a command prompt because now we're at the where the operating system crosses to the physical system. So if I do, and this is going to be a command we'll use a gazillion times, so write it down. ipconfig/all shows me all my IP configuration information. And this looks like my Ethernet controller. And right here is my what's called a physical or MAC address. This identifies my computer at this layer. I communicate from one computer to another by finding out what their MAC address or hardware address is. That's where this layer of communication takes place. MAC address data link layer cannot cross from one network to the other. It's used inside a local area network. How do we go from one network to another? We have to have IP addressing. If we look at my IP config, and you should look at yours also, my address of my computer is 192.168.9.130. That is the specific logical address. Theoretically, my MAC address is unique from any other MAC address in the entire world. There can be other networks that have this logical address. However, we're all separated by routers, so I can have all my own addresses. You can have all your own addresses, and we won't have any trouble. So this is my address. This is my logical address. Transport layer isn't going to be shown here because it's not an address. It's not a location. It's how we get from one place to the other. TCP, Transmission Control Protocol, is a reliable communication method. It uses handshaking to make sure the packet gets where it's supposed to go. UDP is, well, you could think of it as unreliable. That's not really what that stands for. It's called User Datagram Protocol. We use it for streaming, YouTube, Netflix, Prime, all that, where you just have to get most of the packets. We use TCP for everything else because if you're like making a deposit at your bank, you want to make sure that all $425 get there and it doesn't end up being $397.64. So TCP makes sure that every packet gets delivered to the right location and everything is good. These we usually kind of lump together. These are protocols that talk to this part that communicate specifically with applications. So our web browser communicates typically with HTTPS, Hypertext Transport Protocol Secure. So when I'm going to buy things, or just about every website, you're going to see that little lock. That means that everything, and it says HTTPS, that means everything between me and Blackboard and anything else that I'm in is secured. There's very few websites anymore that are not using HTTPS. And there's other methods that like email uses these guys to communicate. We will be seeing and working with this again and again and again. The application layer is the interface between the network stack, is a term that's used. So you can see all this is stacking up. The application layer allows communication between the networking pieces and the application. So the application layer doesn't contain applications. the application, for instance, Google Chrome, communicates with the network at the application layer. Presentation is the encrypting, compressing layer. Session layer just says, I would say, hi, George, how you doing? And George would say, well, hello, how are you doing? Well, we have just established a session. So these three, as it mentions right there, these three are kind of all mixed up together, because they all kind of occur sometimes at the same time. Now, the transport layer we've been through. Guaranteed delivery, TCP, just like FedEx, guaranteed delivery. UDP is, well, maybe it'll get there and maybe it won't, but most of it gets there, so you don't miss a few pixels on your Netflix, do you? Well, not all the packets are getting there. Doesn't matter. Same thing with this video you're watching. Not all the packets are getting to you. Doesn't matter. There's enough that our brain will fill in between everything. And you can't see it. Maybe one pixel out of one screen doesn't make it. You can't see that. So TCP also splits the packet into pieces. So if I'm sending a big file to somebody, it breaks it up into little tiny envelopes, which are called packets, and sends them individually. And then on the other end, they're reassembled. Ooh, come on. There we go. The network layer is, how do I get from point A to point B? This is the addressing. And it's called IP, Internet Protocol. It's a unique address inside the local network that's used to uniquely identify each host. And yep, okay. So data link layer is how your computer knows where to send the electrical signal. In my case, my computer is sending its stuff directly to my router. And so each of them know their MAC address. So let me bring up my command prompt and we'll run a program called ARP. Address Resolution Protocol deals with the MAC addresses. So in my network, this is my router. So my computer knows about that MAC address so that we can communicate physically between each other. That's how the electricity knows where to go. From my computer to this goes to that physical address. The physical address makes the translation from your computer hardware, which is the network card. It makes the translation from the network card, the operating system, to the network card, which then allows direct communication with the firewall. And this layer is just the bits in the air on a copper wire or light. That's it. And there's other types of transmission. Well, everything is either radio, voltage on a copper wire, or light, I guess, yeah. Unless you're passing envelopes around the room like we were doing in class to simulate an analog network. So, there's different names for various stages. We typically refer to the entire thing as a packet. It's just a general term, but there are specific terms. Do you have to memorize those? No. I will refer to it as a packet quite often. So here's a picture. And I'm going to find an animation that shows this and post it. So when my browser is making a request, Firefox makes a request to the application layer. These guys say, okay, well, we're going to do HTTPS and that kind of thing. Then the transport layer says, yep, we're going to use TCP. That's added onto the packet. The network adds on the network address of my computer. It adds on my MAC address. It adds on my physical address. And because I know the address of my switch, which, that's right, I have a switch in addition to my router, but even routers have switches. So the switch reads the electricity, comes in. It looks at the data link layer and says, oh, well, you're heading toward the router. So the switch is called a layer 2 device. The router is what's called a layer 3 device. It has to read the physical wire electricity. It has to look at the MAC address, and it has to look at the IP address to determine where does that packet go. And then on the other end, the web server reads the physical wire from the router, physical electricity, the data link. It says, oh, well, this is where it's going. and it reads it finally up to the application layer, which then connects to the web server. Yes, we'll be going through that again and again and again. And that's pretty much, you better be safe, but I think I've talked enough on this subject for now. We are going to continue to learn more about networks and divide down into all the little pieces that happen. And when we're done, or even now, it's amazing with all the things that have to happen very quickly. Now, for example, let's give an example. If I send a test packet to google.com, all those things have to happen in 7 milliseconds. So 7 milliseconds is not very long, and it all happens that fast. And we haven't even gotten to everything that happens. Regardless, we'll move on with our networking journey.